So here we have this example, okay? Now, let's solve this using the quadratic formula. All right. So again, we have ax squared plus bx plus c equal to 0. You basically have to figure out what a, b, and c are, right? And that's what I'm doing here. See? You know, you just compare the standard form. A is the leading coefficient, your b is the coefficient of x, and your c is the constant term, the term with no letters. Excuse me, the term with no variables. But again, you want to include the minus sign if it's there, as you can see. Let's plug it into the formula, right? Negative b plus or minus the square root, excuse me, b squared minus 4ac over 2a. That's negative 4 plus or minus the square root of 4 squared minus 4 times a times c over 2 times a, as you can see. Good. Right, so we have, again, let me say it again. We have b is 4, so we have negative 4 plus or minus the square root of 4 squared minus 4 times a times c over 2a. And now we have to do a little simplification, of course. Basically, we have to figure out what the radicand here is. I mean, the denominator here, 2 times 3 is 6. 4 squared is 16. 4 times 3 times negative 4, excuse me, minus 4 times 3 times minus 4. That actually becomes plus 48. You have minus a negative, like so. You know, minus a negative becomes addition. So this becomes negative 4 plus or minus the square root of 64 over 6. And the square root of 64, right? 64 is a perfect square. The square root of 64 is 8. So our two solutions are negative 4 plus 8 over 6, which is just, 4 over 6, which is 2/3. You know, I wrote this in lowest terms. The other one is negative 4 minus 8 over 6, negative 12 over 6, which is negative 2. So we get these two solutions. I mean, if you would have factored this, which you could have factored it, you would have to use the AC method. But you can see here with the quadratic formula, you don't have to, which is nice. All right. Do you have any questions about this one? All right. Here's another one. This one's also pretty straightforward. Let's say we want to factor this, solve it using the quadratic formula. So here we have x squared, a is 1, bx, 6x, b is 6, c equals 9, we get this. Okay. So from here, right, we use our formula, we plug it in, like so. Okay, so plug it in, we get negative b is 6, we have negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 9 all over 2 times 1, right? Now what is this equal to? Well, we get negative 6 plus or minus 36 minus 30, square root of 36 minus 36 over 2, which of course is this, as you can see. And of course, this is negative 6 over 2, which is just negative 3. Notice here there's only one solution, right? Mostly because the radical is gone, because you're taking the square root of 0, which is 0. So this is the kind of quadratic equation where there's only one solution. right? In this one, we had two solutions. Here we have one. Let's take a look at this one. X squared plus 3x equals minus 5. Okay. Well, we're going to use the quadratic formula. Notice it's not in standard form initially, right? So you want to get the 5 on the other side here. Now, how do you do that? Well, we just add 5 to both sides. Remember, you want the right-hand side equal to 0. So now here, it's in standard form. Now we can look for our A, B, and C, and then use our quadratic formula. Okay, so from here, A is 1. Remember, if the coefficient is 1, we don't write it. B is 3, and C is 5. Okay, so from here, we get, this is our formula again. Okay, so let's plug in negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 5 over 2 times 1. Which, of course, is just negative 3 plus or minus the square root of 9 minus 20 over 2. And that becomes this. Now, here we're taking the square root of negative 11. Well, that's not a real number. So what does that tell us? There's no real solutions to this quadratic equation, which is equivalent to this equation, to this quadratic equation. I mean, here it's not in standard form, but there are no real solutions, right? So again, yeah?
So if the negative sign underneath the square root, like you can't go any further, it has to
Exactly.
be. Okay.
Right.
What
Awesome
about,
question.
what about if it was just like a regular 11?
If it was just 11, then you would have two solutions.
Okay, can you like show if it was a regular 11, like how you would get the answer for that?
I mean, we will see shortly something like that.
Okay.
It won't be 11, but I'll show you what will happen. So.
Okay.
Okay, you're welcome. Good question. But right, if you have a negative under the radical, in this class we won't have any solutions because our solutions would be complex numbers. And before I get to more examples, let me just point this out. That thing on the radicand here, this is b squared minus 4ac. Well, here it's minus 11. And because of that minus 11, that's really why there are no solutions here. But I'm not sure who asked it, but because I can't see well, if it was positive 11, right, then there would be two solutions. So that radicand really does make a difference here, right? Well, because of that, we give it its own name called the discriminant. So if this is positive, then this equation has exactly two solutions. That's actually what happened. Let me go back to this example. Here, here we actually had the square root of 64. I mean, here 64 was a perfect square, so we could actually evaluate its square root. I mean, we can't always do that. But because this was positive, we still got two solutions. Now, even if for some reason you didn't know what the square root of 64 was and you left it like this, you would still have two solutions. If it happens to be 0, the discriminant, like in the second example, which is here, in this example, then you're only going to get one solution. And if it's negative, as in this case, negative 11, then you have no real solutions. You have complex solutions, as they call them. Those are numbers that deal with that, where you allow the square root of a negative to be a number. But again, we're not doing that. Mostly for time consideration. Okay, I'm going to get to an example, another example now, but are there any other questions? Okay, so let's do this one. So here, again, it's in standard form, right? So we have to get A, which is 1 in this case, right? A is the leading coefficient. And the coefficient, if it's not written, it's understood to be 1, as here. B is 2, as you can see. Negative 1, see? As you can see, you have to include the negative if it's there. Now we dive right in to the quadratic formula. I mean, if I don't tell you which method to use, you can use either method you want. In this example, I'm saying use the quadratic formula. So from here, we get negative b, right? B is 2, negative 2 plus or minus the square root of 2 squared, which is 4, 2 squared minus 4 times a, which is 1, times c, which is negative 1, over 2 times 1. So we get negative 2 plus or minus the square root of 2 squared is 4, but here we have minus a negative. So we get plus 4 over 2, which is this. But here, though, I simplify it. We have simplified radical 8. It was on that worksheet. I did post solutions to it. But basically, we know that radical 8 is not simplified because if you look at 8, the radicand, 4 is a perfect square, and 4 is a factor of 8. Right? Remember, to be simplified, the only factor that's a perfect square is 1. But 4 is a factor, and 4 is a perfect square. So radical 8 is, so 8 is 4 times 2. The square root of 8 then is the square root of 4 times the square root of 2, which is 2 square root of 2.